Question 4. Ethanol reacts with potassium cyanide followed by dilute acid to form 2-hydroxypropane nitrile. So I've drawn ethanol here. I've drawn a cyanide ion, so potassium cyanide, which needs to be in methanol and water, by the way. In methanol and water, the potassium is just a spectator ion. You don't draw that. You put Cn with a minus. The minus can be anywhere. And there's a lone pair of electrons on the C. The arrow goes from the lone pair of electrons to this C, which is delta plus, because this is a polar bond with the O more electronegative than the C. Bonds to that C. The double bond, the electrons from the double bond go onto the O, so that creates a single bond. There's the pair of electrons that have just moved onto the O, and it becomes minus because it's had electrons moved onto it. And this Cn has bonded on. It's lost its minus charge because it's had electrons move away from it. Now here's the acid, followed by dilute acid. Acids make H pluses, and the lone pair of electrons on the O bond to the H and make OH. The O has had electrons move away from it, so it loses its minus, and the H plus had electrons move onto it, so it loses its plus. And there we go, and that's made 2-hydroxypropane nitrile now. Name the mechanism. Well, this is a nucleophile, it's an electron pair donor, and everything is added together, nucleophilic addition. The 2-hydroxypropane nitrile formed in a reaction is a mixture of equal amounts of two isomers. Yes, it's got a chiral carbon. It's got 4 different groups attached to that central carbon there. It's got a chiral or an asymmetric carbon atom. So these are going to have mirror images in enantiomers which rotate plane polarized light in opposite directions. It's a mixture of equal amounts, but if the two enantiomers are in equal amounts, that's called a racemic mixture. And the reason it's a racemic mixture and got equal amounts is because this cyanide ion has got an equal chance of attack from above or below. If it attacks from above, it makes one enantiomer, one mirror image. If it attacks from below, it makes the other mirror image, so you get 50% of each, equal amounts of each, because there's an equal chance of attack from above and below. That's because this C double bond O is planar, so there's an equal chance of attack from each side or above or below. 3D representations of this, so I've got to draw this as a 3D shape. It does say 3D representations, so I've drawn the OH and the CH just flat against the plane. I've drawn the H coming out and the CN going back, but you could have these in any way that you want, as long as then that's mirrored perfectly. N, N, C, 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 OH, OH. Really, that should be HO there. Should be HO, but you probably get the mark for that. CH3, CH3. So these should be exactly reversed, but you'll still get the mark for those if they're not exactly reversed. As long as the OH and the OH are at the top, C's in the middle, CH3 are to either side, as far away left and right, the CN are in the middle, and the H are coming forward. You'll get the marks for it. 2-hydroxypropane nitrile can be used for the synthesis of the monomer, acrylonitrile. Okay, suggest a suitable reagent conditions for the conversion of 2-hydroxypropane nitrile into acrylonitrile. 2-hydroxy, you've got an OH group, and you turn it into a double bond. You're removing water, you're dehydrating it. You need something like concentrated hydrochloric acid. You're going to have to heat that up, so you're going to have to reflux it. You need about 170 degrees C, but as long as you put heat, then that will get you the mark. So concentrated sulfuric acid and heat, you need to reflux it. Draw a section of the polymer polyacrylonitrile showing 3 repeating units. Okay, so we look at the double bond here and we look at what's coming off it. So I've got a C to C double bond, I've got an H and an H, and on this C I've got an H and a CN. I draw 3 of those, then I break the double bonds and I join them together. So I've had a double bond here, I've had an H and an H, these are these 2 H's here, I've had an H up and a CN down, let's say, here, and there's been a double bond and the double bond broke and it formed 2 single bonds. It says that it wants 3 of those units joined together, so I've drawn a second unit and a third unit and joined them together as such.